In this video, we're going to take a look at covalent bonding. To start off with, a covalent bond is formed when two nonmetals react. And so when a covalent bond is formed, electrons are shared so that the element has a full valence shell. And when electrons share, they share to form a covalent bond. So an example of a covalent molecule is water. Now if we take a look at water and we look at the Lewis dot diagrams of each, let's draw hydrogen and hydrogen here. And then oxygen has 6 electrons, so we'll put one on each side and then we'll double up. And so two covalent bonds form in this molecule. So one electron from the oxygen is shared with the electron from one of the hydrogens, and then one electron is shared from the oxygen to the other hydrogen. So this ends up forming two covalent bonds. And the way that we would end up showing that is a covalent bond is shown with a solid line, and that solid line represents two electrons. Okay, one is being shared from each of the two atoms. And then we're going to show the other electrons here on the oxygen that aren't paired up with anything. Okay, so what I just drew was called a Lewis diagram. We need to go through the steps on how to draw Lewis diagrams for covalent compounds. So in order to do this, we are first going to draw Lewis symbols for each of the atoms in the molecule. The single atom is going to go in the middle, and the other atoms are going to surround it. And then step 3 is really key in that any unpaired electrons are going to want to be paired up. They are going to want to create bonds to satisfy the octet rule. So we are going for full valence shells here. And then finally, sometimes you might need to create double or triple bonds to take care of all of the unpaired electrons. So just keep that in mind as we are working through. Let's go through 3 examples now. We'll start with fluorine, or F2. So our first step says that we're going to draw each of the atoms, and then we're going to do the Lewis dot diagram. So for a fluorine, it's got 7 valence electrons. Okay, we'll do the same for this fluorine. 5. And I'm just going to draw them paired here. Okay, so you've got one unpaired electron in each of the fluorines. And our next step then says that we want to pair them up. So the single fluorine, or the single electron from each fluorine, is going to share with the other fluorine to form a covalent bond. Okay, and we're just going to redraw this now so that we're showing that covalent bond. So we're replacing those 2 shared electrons with a line, and then we're drawing the rest of the electrons around it. Okay, and that would be our Lewis diagram for F2, or fluorine. For oxygen, oxygen has 6 valence electrons, so let's go through. Here's our Lewis dot diagrams. Okay, and then we'll do the same for this oxygen. So 2 sides are paired up, and then we've got one on each of the other sides. Now this one, we have each oxygen has 2 unpaired electrons. So it's going to want to form one covalent bond, but then in rule 4, we've still got unpaired electrons here. So in order to satisfy that, these 2 are also going to share to form a second bond. So the final Lewis diagram for oxygen is going to have a double bond, so one coming from each of those two shared pairs of electrons. And then we're just going to draw the other pairs of electrons here on our final diagram. So we're going to go 1, 2, 3, 4, and then 1, 2, 3, 4. Okay, so this is an example of a molecule with a double covalent bond. All right, our last example then, we've got CH4. So following our rules, we're going to draw our Lewis dot diagrams for each of our elements. Carbon has 4 valence electrons. Okay, we're going to draw one on each side. And then we're going to do the Lewis dot diagrams for each of the other elements surrounding it. Okay. Now because carbon's got 4 unpaired electrons, it's going to want to try and bond each of those unpaired electrons. So it's going to form one covalent bond there with one hydrogen. It's going to form another covalent bond with another hydrogen, and then another one with another hydrogen, and one more with the other hydrogen. Okay. So its final Lewis diagram, and I'll just draw that up here, is going to have 4 hydrogens bonded to the carbon, all with single covalent bonds.